Welcome to my YouTube channel. This is Mom Annie.
Hello everyone, I am back. I am your teacher Annie and we'll be discussing about scalar and vector quantities. These scalar and vector quantities, physical quantities, and these two differs from one another. When you say scalar quantity, these are measurement with magnitude. Therefore, it only shows its numerical value, which consists of a number and its units. For example, when you say time, 2 minutes. So we only have a number and its units. Next, mass, where you would say 5 kilograms. It consists of number and a unit. For temperature, let's say for example, that's 36 degrees Celsius. It only describes its magnitude. On the other hand, when you say vector quantity, these are physical quantities of a measurement which describes magnitude and its direction. For example, when you are asked to describe the velocity of an object, you would say its magnitude and its direction. In this case, for example, a car is moving 5 meters per second to the west is a vector quantity because it includes its direction. But if you say that a car is moving 5 meters per second, that is just a scalar quantity. It only says its magnitude, not its direction. Okay. Next, an example of a mass of an object that's 5 kilograms is a scalar quantity. And for vector, we can use to describe the weight of an object when we include the pull of gravity downward against the mass of an object. Let's say, for example, the mass of an object is 5 kilograms. When we want to get its weight, we would consider the pull of gravity, which is 9.8 meters per second downward. Therefore, the weight is a vector, which is equal to 49 Newton downward. That is also equal to the force that a person is exerting towards the earth. Okay, so a vector is represented by an arrow. The length of an arrow describes the vector magnitude, while the arrow's head points towards the direction of the vector. Okay, how can we name a vector? Consider a vector A, which is equal to 30 meters. To name a vector, you have to consider the directions, which are the north, east, south, and west. And it can be named possibly as a vector 30 meters, 30 degrees, a vector 30 meters, negative 330 degrees, or a vector A, which is equal to 30 meters, 30 degrees north of east, a vector A, 30 meters, 60 degrees east of north. You may notice that the angle is equal to 30 degrees and negative 330 degrees here. You have to recall from your mathematics class that an angle that is counterclockwise from the x-axis is positive, or otherwise it is in negative sign. On this case, from x-axis from this direction, that is 30 degrees, and counterclockwise, that is negative 30 degrees, because we know that one revolution is equal to 360 degrees, so you just subtract 360 degrees minus this angle given here, so you'll have negative 330 degrees. This graphical representation of vectors can be used in adding vectors, and there are ways in adding vectors. We have graphical method, and we also have analytical method. So let's run through how can we add vectors using graphical representations. So you can use two methods. We have parallelogram method and we also have polygon method. Parallelogram method is only used if you have two vectors that is being added. If we have two vectors, what you are going to do is to choose the scale. Next one, to draw a Cartesian plane and plot the two vectors, the given forces from tail to tail. Next step is you have to draw two dashed lines parallel to the given vectors to make a parallelogram. Next, you have to draw the arrow that will represent the resultant vector from the origin to the opposite vertex of the formed parallelogram. For example, Force is a vector quantity that uses Newton as the unit. Suppose a force of 10 Newton is applied horizontally to a block. Also, a second force is 5 Newton is applied to an angle of 30 degrees above the horizontal. You have to determine the resultant force that acts on the block. Let's follow the steps. Number 1, you choose the scale. So let's say, in this case, you can go with 1 centimeter is equal to 1 Newton. So therefore, our first force is 5 Newton. So that would equivalent to 5 centimeter. Next, force 2 is equal to 10 Newton. So based on our scale, that is also equal to 10 centimeter. Second, you draw a Cartesian plane and plot the two vectors from tail to tail. How are we going to do that? Let's say this is our first vector, 5 centimeter, and our second force is 10 centimeter, and it is at an angle of 30 degrees. How are you going to get your angle perfectly? You have to use your protractors. Next step, you have to draw two dashed lines parallel to the given vectors to make a parallelogram. Let's draw a dashed line so that this line here is equal to the length of here, and this line here is also equal to the length of our force 1. To get our resultant, you have to draw the line that represents the resultant vector from the origin to the opposite vertex of the formed parallelogram. So in this case, you have to draw this and you measure this line using your ruler, and for you to be able to know what is the value of that, you have to convert the measured value using your chosen scale. For example, if you have measured correctly, approximately the length of this line here, this color blue, would equal to 14.6 centimeter. And let's convert this, recalling our scale, that is 1 Newton is equal to 1 centimeter. So therefore, our resultant value is equal to 14.6 Newton. By the way, why do we have to scale our given quantities? Because we know that 1 Newton cannot be plotted into our paper. However, if we scale our 1 Newton as equivalent to 1 centimeter, therefore we can plot this in our Cartesian plane. So therefore, our resultant force is 14.6 Newton at 10 degrees. So question is, how can you get the angle? Of course, you make sure that you use your protractor. So if you will correctly measure your angle on this part, using your protractor, you would get 10 degrees. Another way of graphing vectors or adding vectors graphically is what we call polygon method, usually known as the head-to-tail method. This can be used when adding vectors which are 2 or more. Earlier, we have identified that parallelogram method are just used when adding vectors of 2. So therefore, if you have more vectors than 2, you can use polygon method. How are we going to do that? Number 1, let's define again the scale. Number 2, you have to draw the vectors in the Cartesian plane. We have to recall that in drawing the vectors in the Cartesian plane, draw the first vector from the origin of the Cartesian plane, and the next two vectors are drawn in a head-to-tail manner, or from the head of the prior vector connecting to the tail of the next vector. Next, you draw the arrow of the resultant displacement by drawing an arrow from the origin of the Cartesian plane to the head of the last vector. You can measure the length of the arrow using a ruler and its direction using protractor again. Next, you use the scale to convert your measurements to the resultant. Let's say, for example, displacement, which is a vector quantity, describes the change in the body's position. Suppose you walk from your house with the following displacement. First, you walk 10 meters to the east. Next, you walk 5 meters to the north. And then another 5 meters to the west. Let's identify that direction 1 is equal to 10 meters east, direction 2 is 5 meters north, and your displacement 3 is 5 meters west. Okay, step 1, let's say 1 centimeter is equal to 1 meter because we know that 1 meter is not easy to be graphed in your paper. It will not fit in. So let's scale 1 centimeter is equal to 1 meter. In this case, displacement 1 is equal to 10 centimeter east, our displacement 2 is equal to 5 centimeter north, and our displacement 5 is equal to 5 centimeter west. Next step, let's draw the vectors in the Cartesian plane in a head-to-tail manner. So our vector 1, that's 10 centimeter to the east. The tail of the first vector must be from the origin, going to that direction, that is going to the east. And your next vector must be drawn from the head of the first vector, going to its direction, that is north. Make sure that this is 5 centimeter. Next vector must be drawn from head of the last vector going to the west, which is 5 centimeter west. Next, because you have drawn that in a Cartesian plane, what you do is to draw the arrow of the resultant displacement by drawing an arrow from the origin, on this case here, going to the head of the last vector. Okay, this is our displacement 1, displacement 2, and this is our displacement 3. So this violet is our resultant displacement. So if your measurement is correct, you should get about 7.1 centimeter and 45 degrees respectively. Take note to use your ruler and your calculator. To make sure that your answer is in centimeter, just remember the scale that you used. So approximately we will have 7.1 meters northeast, because we know that our scale earlier is 1 meter is equal to 1 centimeter. Next way of adding vectors is what we call analytical method. Is an accurate tool to get the resultant vector. This uses basic concepts of trigonometry, trigonometric functions, a right triangle with sides A and B and its hypotenuse, which is equal to C. This right triangle here are related through the Pythagorean theorem. When you recall your mathematics, according to Pythagorean theorem, A squared plus B squared is equal to C squared. With reference to one of the angle of the right triangle, you can write the number of ratios of each side using SOHCAHTOA. So, which means sine of the angle is equal to opposite side divide your hypotenuse. Ka, which means cosine of the angle times its which is equal to adjacent side over its hypotenuse. And TOA, tangent of the angle is equal to opposite side of the right triangle divided by the adjacent side of the right triangle. You have to take note that if you know the x and y components of the vector, you can find its magnitude using Pythagorean theorem. According to Pythagorean theorem, A squared is equal to B squared plus C squared. Okay, let's apply that in this example. Find the x and y components of a displacement vector with magnitude of 10 meters and direction of 40 degrees with respect to the x-axis that is shown below. Okay, how are we going to do that? We know that the x component is equal to our displacement times the cosine of the angle, because we are looking into the x component, so cosine of the angle. So just substitute the value of the displacement, which is equal to 10 meters, times the cosine of the angle. Our angle at 10 is 40 degrees. So we'll get our x component is equal to 7.44 meters. To get our y component, we can use our displacement in y is equal to our displacement times the sine of the angle. Substitute the value of our displacement, which is equal to 10 meters, multiplied by the sine of 40 degrees, and you will get our displacement in y is equal to 6.43 meters. Okay, let's use the identified value in answering our next example. Let's compare now if our answer will get the identified or the given displacement earlier, which is equal to 10 meters. Find the magnitude and direction of the displacement vector using our x component is equal to 7.66 meters and our y component is equal to 6.43 meters. Our answer must be expressed and our displacement vector is equal to our displacement and the angle of the vector. How are we going to do that? Recall that our Pythagorean is a squared plus b squared is equal to c squared. So displacement is equal to the square root of x component squared plus our y component squared. You just substitute the value of our x and y component and approximately you will get the final answer of 10.01 meters. To identify the angle or direction of this vector with respect to the x-axis is computed as follows. You can use the TOA or the tangent of the angle, which is equal to opposite over adjacent. So recall our x component is 7.66 meters, our y component is equal to 6.43 meters. Just substitute the value. On this case, tangent of the angle is equal to opposite. On this, our opposite is our y component, which is equal to 6.43 meters, divided by the adjacent of our angle is our x component, and that is equal to 7.66 meters. So tangent of the angle is equal to 0.8394. And to get our angle, you divide both sides by our tangent. So therefore, your angle is equal to the inverse tangent of 0.8394. Using your calculators in degree mode, you will get that the angle is equal to 40.01. If you can recall from the given problem earlier that vector is equal to 10 and the angle of that vector is equal to 40 degrees. So that is correct. Unit vector is a vector with a magnitude of 1 used to describe a direction in space. The symbol of unit vector is in bracket or a letter with hat, which is placed above the unit vectors to distinguish it from the ordinary vectors. The unit vectors used to point in the direction of positive x, y, and z axis are the following. For x-axis, we use I with a hat over there, our positive y-axis, our j with a hat over there, and our x-axis, k with a hat. Okay, so you can write the vector in terms of its component as vector A is equal to vector A in x component, your y component, plus your z component. Or you can also write vector A is equal to your x component I plus vector y component j plus vector A component of z and your k. So the magnitude of a vector can be calculated by getting the absolute value of vector A, which is equal to the x squared plus y squared plus z squared, or unit vector is equal to vector divided by the vector's magnitude. Example, find the unit vector of vector P for the given vector 12i minus 3j minus 4k. So let's find the magnitude of the given vector. Recall that this one is our x, this one is our y. The number beside our k is our z. So just substitute the values for the vector P. Absolute value of vector P is equal to the square root of our x squared plus y squared plus z squared. In this case, our x squared is 12, this one, squared plus our y is 3, you square that, plus our z is 4. So 12 squared is 144 plus 3 squared is 9. plus 4 squared, that is equal to 16. You get the sum of that, you square that, and you will get 13. Therefore, the unit vector P for the given vector 12i minus 3j minus 4k is equal to 13. So let's use this magnitude to find the unit vector now. To get the magnitude, P is equal to xi plus yj plus zk is divided by the square root of x squared plus y squared plus z squared. Substitute the values. 12i minus 3i minus 4k divided by the value of this is equal to 13. The unit vector in bracket form would give us 12 over 13, comma, our component y is 3 over 13, comma, 4 over 13. I hope that you have understood our lesson in this video. If there are queries and clarifications, I am still open for your chat in our group chat or in Messenger. Thank you for today.